6-3, day 3, we are finishing up understanding logarithms, and we're going to graph some logarithmic functions as well. So there'll be 2 graphs. If you want to grab some graph paper, you can. If not, we'll just sketch it in our notes. All right? Remember when we are asked to find the inverse. That's what we're going to do on these first few examples. We're finding the inverse. Remember, if there's an f of x, we're going to change that to y. By definition, when we are asked to find an inverse, we must switch our x and y variables, and then we'll solve for a y, okay? So this first guy is y equals the natural log of 5x. We have to remember natural log, okay, that is written as ln, but what is the base really of that natural log? Yep, log base e. I need to know that because when I do go to do my log loop, I need to start at the base, and if I don't have the base visible, I don't know what I'm starting at, okay? So on this first step, I'm going to switch my x and y, but I'm also going to rewrite my natural log as log base e. So it'll be x equals log base e of 5y. So from here, we can now find the inverse. We talked about logs and exponentials yesterday, about them being inverse. So if I start with my function and it has the word log, when I write my inverse, it should not have the word log because it's going to be exponential, meaning it'll have a base and a power. So we start at our base always for our loop. So we will rewrite this as e, and then we loop it in the direction of our equal sign. So it'll go from e to x, so we'll have a power of x, and then from x to 5y. From here, yesterday, we usually just had it equal y, and we were done and boxed it. But now we have 5y, so I just have to do one more step. How do I get the y by itself instead of multiplying? Divide. Perfect. So we just divide by 5 on both sides, and we get e to the power of x divided by 5 equals y. That's our inverse. It started out as y, so you don't have to write the inverse notation for this guy. You can just leave him as equals y. This next one, we'll scoot it up a little bit for you guys. We have y equals the natural log of x plus 3. The parentheses matter. With addition, it's really important to, if it's taking the whole natural log of that entire sum, you gotta have parentheses around it. I can't just drop them off. So that x plus 3 is kind of stuck together until nothing's left and on one side. So don't get rid of the parentheses. I'm gonna do the same thing as the problem 1. Switch my x and y. Rewrite my natural log as log base e. Oops. Then I do my loop again. Always start at the base. The base is e. So that's going to be my base for my exponent. It'll be base e. Go in the direction of the equal sign. So then I get to an x. That's my power. And lastly, it'll equal this entire thing, y plus 3. Notice at this point, I dropped off my parentheses because it's the only thing on that side. So I don't need parentheses saying, hey, these are together. They're the only things on the right side. Same as before, I just have one more step. This time, what are we going to do with the 3?
Subtract 3.
Yeah, subtract 3 from both sides. So we have e to the power of x minus 3 equals y. And that's our inverse. And again, it started with y, so no need for the inverse notation. I think this last one, I did do function notation, so f of x instead of a y there. F of x equals 5 minus log x. So this is a little different. We have, not only do we have function notation, so I do have to change that guy to a y before I switch my x and y values. But I have another issue too. The ones before all had a base showing, or if I rewrote it with a natural log, right? This guy doesn't have a base. It has log, but not a base. So what kind of base do we have there? 10, yes. Okay, so at this point, I'm going to write that base 10 in as well. Anytime we have just log, that's our common log, and we have to remember that common log really has a base 10. It's like powers of 1. We don't see them, but they are there. Same idea. The next problem, so now I resolved that one. My next problem is the other two only had log, base, and then something, right? We didn't have anything being added or multiplied in addition to the log. This time we have this extra 5 piece, so I can't do my loop until I get rid of everything that's not part of this log. So there's 2 ways I could do it. I could subtract my 5 and move it, but then that leaves me with a negative log. So I would just have to make sure I kept in mind that I have a negative and then change it later by either multiplying by -1 or dividing by -1. Totally fine to do. Another way, if you prefer to just make this guy positive, is add log base 10x to both sides and then subtract your y, and then everybody has the same correct signs. I don't care which method you use. I'm going to subtract my 5 first from both sides, and then I'll just make sure I don't forget the negative and to fix that. Oops, I almost forgot to switch I did that last class too. I almost forgot to switch my x and y. Can't find the inverse if I don't switch them. So I'm going to make that x and this guy y. Woo. Moving too fast. Okay, so we have x minus 5 equals negative log base 10 of y. And like I said, to get rid of this negative in front, if you just multiply by a -1 or divide by -1, all it does is every sign has to get changed on the left and on the right. So instead of a positive x, we'll have a negative x. Instead of -5, we'll have +5. Instead of negative log base 10 y, we'll have a positive. Okay? Now that it's a positive log, there's only the log stuff going on. Now I could do my loop just like before. Start at my base. This time my base is 10. So my base for my exponent will be 10. I loop around towards the equal sign, which is again to the left. And now I have 2 things. It's not just x. Everything on this side that I run into, that entire negative x plus 5, is going to be my power. It's going to be my exponent. And so whenever I have more than one thing in my exponent, I will put parentheses around it so I don't think the plus 5 is like big like the 10. All right? And then last, we hop back over. Whoops. And it just equals my y. Y is solved. The last step that I would do, because they started with f of x, is just change your y to inverse notation. That would be the only thing. And then we're done. So this one, kind of zoom out there. This one here, we are going to still find the inverse. We're still making sure we switch our x and y. We're still solving for y. So again, just like before, we're going to change that f of x into, there we go, into a y. And I'm going to switch my x and y values. So x now here equals e to the power of y minus 3. And I'm going to put that guy in parentheses so I don't think my 3 is a big 3. If it starts out as exponential, there's no word log. There's no natural log going on here. Okay, so my inverse better have those words, either log or natural log in the end. Because by definition, inverse of an exponential will always be a log. Okay, so when I do my loop here, I'm still starting at the base. The base for exponents is e here. Okay, it's the one that has the power. That's our base. So we start here. And because I'm starting at base e, I'm writing log base e. Okay, that's my first step when I go from exponential to a log. I don't want to forget the word log, or else then I'm not making an inverse function. Equal sign still tells you what direction to move. So we have log base e of x, and then we hop over and it equals y minus 3. And again, there's only y minus 3 on that right side, so at that point I just drop off my parentheses. I don't need them if it's the only thing on that side. Last thing, just add our 3 to both sides. Plus 3, plus 3. So we have log, I'm not going to write log base e because what can I simplify log base e to? The ln, the natural log. Good. So I'm going to write ln, because that replaces log base e, of x plus 3 equals y. Notice I do not have parentheses around the x plus 3 because natural log is only for the x, and then it's like, okay, I found that answer, now I add 3. If you accidentally put parentheses around the x plus 3, it would be wrong because you'd be adding 3 before you took the natural log, which wouldn't give you the same answer. So don't put parentheses when you don't need them, and don't get rid of them when you do need them. And then just change your inverse notation. So at this point, I'd probably just erase my y and write f power of -1 of x. That's our inverse notation for functions. Similar one here. We have f of x equals e to the power of 2x. So same idea, same process, all right? I'm going to show you both. I'll have you guys try those too, okay? I'll zoom them in so you can see them. So try number 5 and then try number 6. Y equals 5 to the power of x plus 6. Notice the plus 6 is not in the power. It is a big number just like 5 is. So this first one, switch my x and y's. So x is going to be here. And then it's e to the 2y power. Do my loop starting at this base. So log base e, of x, moving too fast, of x equals 2y. Log base e can be written as ln. And then I can divide by 2. And at this point, I would just write it in inverse notation. So I would write, instead of y there, I'd write my inverse of x there. Only because it started with f of x, okay? And again, natural log of x, and then that whole thing is divided by 2, not just the x is divided by 2. So make sure your line extends and covers that whole ln x. Questions on that guy? All right. This last one, when I switch it, I have this extra piece, right, of this plus 6. Just like with logs, I can't have extra pieces before I do the loop. It has to just be that exponential or that log, okay? So we're going to subtract the 6 first before we do our loop. So x minus 6 equals 5 to the power of y. Now we're good. Start at our base, log base 5 of this entire thing. Since there's more than one piece, I do require that I put parentheses around that x minus 6. So if you forgot the parentheses, put them in, please. And then it equals y. Because without those parentheses, you would just be taking the log base 5 of only x and then taking that and subtracting 6. And that's not what order of operations would do. It would say, okay, you have to minus 6 first and then take the log base 5 of that answer. So be careful with your parentheses. Don't lose them. Don't add them in when you don't need them. All right, our last kind of examples we're going to do today is graphing our log functions, okay? So we have 2 steps, and I guess you can kind of split 2 into 3 steps if you wanted. But the first step is we are finding the inverse, okay? And this is for log functions, so this is not for anything else. I wouldn't find the inverse for a linear function, right? Because I could just type those in. The reason why I find the inverse for log functions is because the only logs I could graph is the common log and the natural log. And like we just found, the last answer was log base 5. I wouldn't be able to graph that as is, okay? So that's why we find the inverse, because inverses are exponential functions, and we can graph those. We can graph 2 to the power of x, 2 plus, 3 to the power of x, or 2/3 to the power of x. Whatever it is, we can graph any exponential function. We just can't graph every log function. So we needed another method, okay? And we're going to use the table of values of that inverse, okay? So once I find my inverse, the next step is to look at the table of values. And when I write them in my notes, I'm going to actually switch the x and y values. Because by definition, the inverse switches x and y. So if I have the inverse and I want to graph the original, all I have to do with those points is switch them. So say the point's 2, 3, I would switch it and write 3, 2 and graph that instead, okay? And then I'll talk about how to figure out the shape, because sometimes it's weird figuring out the shapes, so I'll show you how to do that too, all right? Use the table of values and switch X and Y values. Those are kind of the main points there for your step 1, 2, and 3. There we go. Kind of was cutting off my words there. So we just practiced finding the inverse of these. So that's what we're going to do first. So we have f of x equals log base 3 of x. So just like before, find that inverse. We're switching the x value with the y value. And remember, our y is the same as f of x. That's why I put the x first. Okay? From here, we do our loop. Base 3, that means my exponent will have a base 3. I go in the direction of the equal sign. So next, it's a power of x, and then last, it equals y. So this exponential function is what we're going to put in calculator, okay? Because I want the table of values from this guy in order to find the table of values for the original. So the first point that I could use on the table of values that I'm seeing is 0, 1. So we have to switch it. We'd write it as 1, 0. Okay? Because we're trying to make the table of values for that original function. So we can't use what we have on our screen because that's their inverse. We have to switch them. So then the next one is 1, 3. So then I'd write 3, 1. The next one on my graphing calculator is 2, 9. So I'd write 9, 2. And then the one after that is 327, but I'm not going to be able to fit that on my graph, so I'm going to stop here. Okay? So these are the points you graph. Points you graph. Okay? That's what we're going to do now. So let's do it. 1, 0. 1, 2, 3, 1. 9. I don't even know if I could fit 9. Let's see. 4, 5, 6, 7, 8, 9. Yeah, I'll go over here. This is 9. 9, 1, 2. Okay? It kind of looks a little flat, and this is where some of you guys had a hard time with on the last chapter test when we went to graph things that weren't perfect straight lines. Sometimes we made them straight lines because their points looked like straight lines that we could graph. This is where I think it's helpful to look at the shape of the inverse. Okay, so now that we have the points for our function, okay, I know whatever this is, it's going to be f of x. I just don't know my shape yet. I'm going to look at my graph that we just found on our calculator because inverses have to reflect over that diagonal line, and I'll draw it in with green here. Okay, this diagonal line, y equals x, every set of inverses reflects over that, which means it's a mirror image. So if I know what the original function looked like, I can mirror image to make sure I graph my inverse correctly, okay? And so I'm going to look at my shape, and I'm just going to sketch it out here, okay? Let's see. Yeah. That's gone through this guy. So here's my 3 to the power of x. Okay, I'm labeling it since I'm putting 2 graphs on. If you put 2 graphs on, please label them so I know which one's which and I can give you credit for it, all right? So if I'm trying to mirror image this, that tells me that this guy is looking like this, okay? And I'm not gonna do like a weird curve or a solid straight line because that's not what the image was, okay? So using the picture of what we have on our graph to help us sketch what we need, it's a good idea. All right, f of x equals log base 1/2 of x. And we're going to do the same thing. We're going to graph it. So we have to switch, we have to switch our x and y placement. We have to do our loop to find our inverse. this is what we're going to plug into our calculator. Casios have a fraction button. TIs, if you do not put the parentheses, you will be wrong because your TI will do 1 divided by 2 to the power of x. And only 2 will get that power of x if you do not put your parentheses in correctly. So TIs, in your notes, please put your parentheses so you know I have to type those in, okay? We'll get our table of values. And then don't forget, when we do our table of values, we're switching them, okay? So let's see. I can't fit negative 416, but I'll go to the next one. So negative 3, 8 would be 8, negative 3. Negative 2, 4, 4, negative 2. Negative 1, 2, 2, negative 1. And then 0, 1 would be 1, 0. Okay? So just make sure you switch them back before you graph them. So 1, 0, 2, negative 1, 4, 1, 2, 3, 4, negative 2, and 8. 1, 2, 4, 5, 6, 7, 8. 1, 2, 3. So again, I kind of see a curve going, but I always double check to make sure that I'm doing it correctly. And again, this inverse, that line of reflection, is always that diagonal y equals x. You don't have to draw that in. I just find it helpful so I can see it and I can kind of visualize, well, where would this be reflecting? How would it mirror? And so this guy is like this. I have a point here, and then I have, yep, so this is going like this. Okay, and this is my 1/2 to the power of x. Okay, and so I have to mirror. Notice it crossed over that line of reflection, which means my inverse will also do the same. And so when I do it, I'm looking at this guy right here, okay? Because when I fold it in half, they should match up and line up. And this is my original function, okay? If you guys have it on paper, like your test or anything, and you wanted to fold it just to double check, it's a lot easier than the whiteboard. So rest of the time, we're gonna do homework. All right, get those submitted before Monday for our quiz.